Have you ever stopped to think about what actually keeps the lights on in your house? I'm not talking about the wires on the street or the switches on your wall. I'm talking about the invisible heart of the entire power grid. Right now, the United States is facing a silent and dangerous crisis. Our power transformers are aging, and there simply aren't enough new ones to go around. Without these colossal machines, the electricity generated at power plants would never reach your home. It would simply fry everything in its path before it even left the station. Today, I am taking you inside a place where very few civilians are ever allowed to enter. This is a high-voltage transformer gigafactory. Here, steel is sliced by lasers with micron precision. Copper is wound by high-speed robots, and engineering reaches levels that feel like science fiction. We are talking about machines that can weigh as much as a Boeing 747, and are built to survive 50 years of relentless storms, heat waves, and hurricanes. Prepare to witness the birth of the giants that are, quite literally, saving the American power grid. It all begins with the core. If a transformer were a human being, the core would be both its skeleton and its brain. But this isn't just any ordinary metal. We use grain-oriented silicon steel, or This material is a miracle of modern metallurgy, specifically engineered to allow magnetism to flow with the absolute minimum amount of resistance. Imagine massive coils of this shiny high-tech steel, each weighing several tons, being unloaded into the factory. The process starts at laser cutting tables that operate with a precision of 1/100th of a millimeter. This is a zero-tolerance operation. If these steel sheets don't fit together perfectly, the finished transformer will vibrate, overheat, and eventually suffer a catastrophic failure. Watching the fiber laser glide over the steel is almost therapeutic. But what comes next is a display of pure robotic intelligence. Imagine assembling a 50-ton jigsaw puzzle where every single piece is as thin as a sheet of paper. This is where the robotic stacking arms come into play. In the past, this was done by hand. But in 2026, the speed and accuracy required are beyond human capability. These laminations are stacked in alternating layers to prevent energy loss from eddy currents. Up close, the core begins to look like a futuristic metal sculpture. The robots work in perfect harmony, placing each blade in its exact coordinate, while engineers monitor the flow via high-resolution tablets. Without this perfectly assembled core, the transformer would be nothing more than an expensive pile of useless metal. If the steel is the skeleton, the copper is the circulatory system. This is where the real value of the factory lies. Copper is one of the most coveted metals on Earth, and we use miles of it in every single machine. Welcome to the winding hall. These vertical winding machines look like lathes from another planet. The copper wire, often coated in a specialized high-purity insulating paper, is wound around heavy-duty cylinders made of high-density pressed cardboard. Every turn of the coil must be perfectly aligned. A single overlapping wire or a slight misalignment could cause a 500,000-volt arc that would turn the transformer into a fireball in milliseconds. The tension in the air is palpable, matching the literal tension of the copper being pulled by the machines. It might surprise you, but in a multi-million-dollar machine, what prevents a total electrical disaster is actually paper and wood. However, this isn't the paper from your office printer. It is high-purity craft paper and densified laminated wood. In this area, moisture control is so strict it feels like a NASA laboratory. Workers wear specialized gloves to ensure that even a drop of sweat doesn't contaminate the insulation. Any impurity, any speck of dust, or any trace of moisture can create a path for a fatal electrical arc. This delicate manual work stands in stark contrast to the raw brutality of the steel we saw earlier. It is the ultimate union of heavy industry and artisan craftsmanship. Now comes the moment everyone in the factory anticipates: the marriage. This is when the electrical components, the copper coils, are joined with the magnetic component, the steel core. This combined structure is known as the active part. Watching a massive bridge crane lift a 20-ton copper coil with the delicacy of a surgeon is breathtaking. The crane operator is one of the most respected figures here, holding millions of dollars of equipment in the tips of their fingers. When the coil slides over the core leg and the fit is perfect, You can hear the entire team breathe a sigh of relief. The heart of the transformer finally has a heartbeat, but it isn't ready for the world just yet. Now, the transformer's greatest enemy takes the stage: moisture. Even the air we breathe contains too much water for these machines. If a single molecule of water remains inside, the insulating oil will eventually fail. The active part is placed inside a massive vacuum chamber, or a vapor phase autoclave. Here, the pressure is dropped to near vacuum levels while the temperature rises. The goal is to extract every single atom of water from deep within the fibers of the paper and wood insulation. This process can last for days, and the wait is agonizing but essential. This is the baptism of the transformer, preparing it to withstand decades of heavy-duty service. While the internal components are being dried, another part of the factory is building what can only be described as a steel fortress. The tank of a high-power transformer is not just a box. It is a reinforced pressure vessel designed to hold tons of oil and survive 50 years of brutal weather. Huge plates of carbon steel are welded by robotic arms that ensure not a single microfissure exists. Every weld is checked with ultrasonic sensors and fluorescent dyes. After welding, the tank is grit blasted and coated with an electrostatic epoxy paint that makes it immune to corrosion. Whether it's headed for the salt air of the coast or the freezing humidity of the north. Once the active part emerges from the vacuum chamber bone dry, the tanking operation begins. It is timed like a Formula One pit stop because every second of exposure to the humid factory air is a risk. The core and coils are lowered into the tank with only centimeters of clearance. Once inside, the heavy steel lid is secured with hydraulic torque wrenches. The transformer is now a hermetically sealed time capsule. Nothing goes in and nothing comes out. Next, we inject the lifeblood of the machine, high-purity naphthenic mineral oil. This oil has two vital jobs. It acts as an insulator to prevent sparks from jumping between coils, and it acts as a coolant, carrying heat away to the external radiators. The filling is done under a vacuum to ensure no air bubbles are trapped inside. We might use over 100,000 liters of oil for a single uniter, massive investment in industrial chemistry. Finally, the horns of the monster are installed, the white porcelain bushings. These are the entry and exit points for the power. Without these giant insulators, the 500,000 volts would jump straight to the steel tank and cause an immediate explosion. Now comes the most dangerous and exciting part of the process: the high-voltage laboratory. Before it can leave the factory, the transformer must prove it can survive the worst that nature can throw at it. We are going to simulate a direct lightning strike. In a darkened, cavernous hall, a massive impulse generator builds up millions of volts. Suddenly, a blinding blue-white arc jumps to the bushing with a sound like a cannon shot. If the transformer survives this trial by thunder without any internal damage, it is officially cleared for duty. Engineers monitor the results on high-speed oscilloscopes, looking for the slightest tremor in the wave data. It is science at the absolute edge of controlled destruction. Once approved, the challenge of impossible logistics begins. How do you move a 450,000-pound machine across the country? We use specialized trailers with over 100 wheels to distribute the weight so it doesn't crush the highway. The route is planned for months. Bridges are reinforced, and power lines are temporarily lifted. Moving at only 5 miles per hour, the convoy is a monumental parade that stops traffic and draws crowds of amazed onlookers. Finally, the giant arrives at its destination, a modern substation. It is jacked into place, connected to the grid, and begins its 60 Hz hum. That giant we saw born from raw steel and copper is now responsible for keeping hospitals running, schools lit, and millions of homes connected. The birth of a transformer is the ultimate testament to human ingenuity, the transformation of raw earth into a tool of almost divine power. The next time you flip a light switch in the middle of the night, remember the heat of the forge, the precision of the robots, and the laboratory of lightning. Progress doesn't happen by accident. It is built with steel, copper, and the courage of the engineers who power our world every single day.